Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. I bet for the entire first semester you didn't think the most exciting thing you would be doing was geometry during your day, but hey, with COVID going on, we're all just sitting at home. I'm here to entertain you. So let's get started on this thing. Let's go ahead and jump over to our PowerPoint. Just like before, I am working in PowerPoint, so please forgive me if the inking system messes around on us. Also, I've got our calculator pulled up because, just as a warning, we're going to jump off the deep end here in about 15 minutes. It's not really that bad. Just letting you know we're going to be using radians for the first time. Actually using them, not just talking about them. So, first off, vocabulary. Central angle is an angle. Let me jump this guy out of the way, whose vertex is at the center of a circle and whose sides are the radii. So what we've got going on here is that anything that comes out of E, or any two radii that come out of E, form a central angle. So here angle CEF is a central angle. Also CEG is a central angle. You can compose up more, or go across more than one radius here. So also angle HEC is also a central angle. Now, a central angle is going to separate a circle into two arcs, the major arc and the minor arc. So, our major arc is the longest arc connecting the two endpoints on the circle. So, let's take angle CEF. The longest distance around the circle from C to F is to go counterclockwise around this way. That would be our major arc. We've also got the minor arc, which is the shortest connecting path. So to go from C to F this direction is our minor arc. Now, a semicircle is an arc with endpoints that lie on a diameter. I don't have one drawn here, but let's just pretend I can draw this correctly. And let's pretend that that is a diameter. Then, in that case, either direction to the left or to the right would be a semicircle. Pretty easy. Now, here's what you need to know about your central angles and their arcs. The sum of the measures of the central angles of a circle with no interior point in common is 360. Now, here's what we mean by that. If I take all of the central angles, so if I take CEF, come on, CEF, and then I add into that FEG, then I add into that GEH, and then to the last part, HEC. All of those add up to 360 because together they make a full circle. Notice that's what this is all about, no interior points. Okay, so it's not like I could say CEG plus CEF because point F is an interior point there. Next up, the measure of minor arc is less than 180 and equal to the measure of its central angle. I mean, think about that. If we're going the shortest distance, one we used earlier was from C to F. Let me use a different color here because that one's, it won't let me choose a different color. Okay, I can only highlight in yellow. Okay, we used C to F as our minor arc earlier. Well, this is less than a semicircle. The shortest distance has got to be less than 180 degrees because 180 degrees is half of the circle. Now, that also is saying that it's equal to its central angle. So if angle CEF, if that was 20 degrees, and let's make that 28 degrees because I messed up, then the arc itself also is 28 degrees. The measure of major arc is 360 minus the measure of the minor arc. So our major arc here, all the way around this way, is going to be 360 minus 28, which is going to be 332 degrees. Okay, measure of a semicircle is 180, since that's on a diameter and it's exactly half a circle. That's pretty self-explanatory. Two minor arcs are congruent if and only if their corresponding angles are congruent. So here's what we mean by that. These two arcs, let's say arc CF and arc HG, are congruent only if their central angles, HEG and CEF, if those are congruent. That's the only way two central angles get to be congruent to one another. Next up, the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So again, let's say that this guy was 20 degrees and this guy was 50 degrees. Well, then the measure of the arc here, CEG, would be 70 degrees. The reason for that is if this is 20, then this angle here is also 20. If that's 50, that angle is also 50. So these two together equal 70. Therefore, they all are 70. Basically, all of our properties of angle addition also apply to arcs. So let's go through. Find the value of x. Well, I know that all of the angles on the interior of a circle or going around a single point equal 360 degrees. So to find x, what I know is that x plus 120 plus 90 equals 360. So that gives me x plus 210 equals 360. And now we're going to subtract 210 off. So that's going to be x equals 150 degrees. Number 2, we want to find our value of x. Now in this case, I cannot add everything up to 360 degrees because, well, I guess I could say that here, this is also 75 degrees because of vertical angles, and then this is 7x plus 2 because of, no, actually take it back. That's not, because those aren't vertical angles. But that's actually reading me down the wrong path here. Notice that we have a diameter AD. That means that everything on this side, on the top side, sums to 180 degrees. So that means that 75 plus 5x minus 5. Why does that keep on going away? Plus 7x plus 2, it disappeared again, equals 180. We just know there's an implied minus sign right there. We just can't see it because it doesn't want to hold on to it. Okay. Now we're going to combine like terms and solve. So we've got 5x plus 7x makes 12x. Then we've got 75, and there's our hidden minus. Minus 5 is 70, plus 2 is 72, equals 180. Let's go ahead and subtract 72 off. Gives me 108. And that's one that I should have memorized, but I don't. 108 divided by 12 is 9. So x equals 9. Remember, if I'm going too fast, you can always just pause the video right here before we move on to number 3. All right, now you can see on this one are examples of how we write major and minor arcs. Whenever we have an arc written with the arc symbol and only 2 letters, you are always going to take the shortest path between those two along this edge of the circle. So arc BA starts at B, goes to A along the shortest possible path. If I give you 3 letters, you've got to start at A, travel to B, but you must pass through C in the process. So on this one, we're going to start at A, we're going to end at B, but we've got to go through C down here. So we've got to go the back way, and that's how we make a major arc. A major arc will always be labeled with 3 points on the edge of the circle. Okay, so segment BD and AC are diameters. That's important because we know that those are going to divide the circle into 180 degree arcs. Identify BA, ACB as major, minor, or semicircle. So BA, we actually already kind of talked about that. BA is minor. ACB is a major arc. And now for the measures of it, BA is just going to be the same as its central angle, so it is 44 degrees. 44 degrees. And then ACB, this major arc across here, is just 360 minus 44. So we've got 116 degrees. Not 100, I'm sorry. 316 degrees. Erase. 316 degrees. Example 4, BD and AC are diameters. We want to identify BC and CD as major, minor, or semicircles. All right, so arc BC is this arc here. That is going to be, looks like a minor arc. And let's say that the measure of BC, that's the proper way of writing it, the measure of arc BC. Well, I know that AC is a diameter, so this whole thing from A all the way around to C is 180 degrees. So therefore, BC is going to be 180 degrees less this 44. So the measure of arc BC is equal to 136 degrees. Now let's switch our colors here and do it in green for arc CD. CD right here is, it doesn't like it apparently. Arc CD is a minor arc. And since these two are vertical angles, that means that this angle here, COD, is also 44 degrees. Therefore, the measure of arc CD is also 44 degrees. All right, BD and AC are diameters. Let's try BCD. Now it tells me that B and D are the endpoints of a diameter, which means that BCD would have to be a semicircle. Therefore, the measure of arc BCD is equal to 180 degrees. Now, AD over here, we'll do this one in blue, over here is less than a semicircle, so AD is a minor arc, and the measure of arc, not angle, I'm sorry, of arc BD is 180 minus 44, because again we're subtracting out this piece, which again gives me that exact same measure we had earlier of 136 degrees. All right, example 6. Refer to our circle graph. We want to find the measure of arc BC. What looks to me like BC is this arc here, and it looks like that contains 39% of the possible degrees. So we know that the measure of arc BC is going to equal 0.3, help if I could write correctly, 36 times the total number, no, 39. I apologize. 0.39 times the total number, which is 360 degrees. Therefore, the measure of arc BC, that's definitely not one that I have memorized. So 0.39 times 360 is going to be 140.4 degrees. All right, find the measure of arc ACB. Well, ACB is our major arc that wraps around the right side, and that one is everything except for 24% of the circle. So 100 minus 24 is going to be 76%. So the measure of arc ACB is equal to 0.76 times 360. Well, jump to the calculator, 0.76 times 360, and I've got that the measure of arc, okay, you know there's supposed to be an A there. It's just not one to go. Whatever. equals 273.6 degrees. You know what? If I just get rid of all this and say equal, then I'm referencing the thing on the left on the one above it. There we go. 273.6 degrees. All right, find the measure of arc IJK. IJK is here. Notice that here I have a 3-letter name for a minor arc. That is perfectly fine. If there's 3 letters, you just follow the roadmap, and my point is that 3-letter names do not necessarily have to be major arcs. They can also be minors. All right, so it looks like IJK, it looks like this whole thing here is a semicircle. And so we're going to subtract out the 32. So the measure of IJK is going to equal 180 minus 32 degrees. So therefore it equals 148 degrees. All right, next concept. Excuse me. An arc is part of a circle and its length is a part of, an arc is a part of a circle and its length is a part of the circumference of the circle. So an arc length is just a portion of the circumference. Now, the arc length can be found using this formula. Arc length L equals x over 360 times 2 pi r. Now, notice what we're doing here. This is just our circumference formula. This right here, x over 360, is essentially a percentage of the circumference. Here's what I mean by that. If x was 90 degrees, well, 90 divided by 360 is 0.25. That's forcing us to give 25% times the entire circumference. So it's just x over 360 times 2 pi r, and all we're saying is percent of the circle times circumference of the circle. So let's find the length of arc AB. So AB is this guy here. So our arc length, and let's see if it gave us the, the length of AB, notice we got a new notation there. The length of AB is equal to, and it was x over 360 times 2 pi r. So x is our angle measure, 135 divided by 360 times 2 pi, and radius is 8. Now, I want you to think about all this as essentially being over 1. I'm going to go ahead and simplify this as much as I can, all right? So that gives me, let's leave the pi on the end. 135 times 2 times 8 is 2160. 2,160 over 360, and that pi is also in the numerator. That's what I mean by leave it on the end. Now, let's see if 2160 divided by 360, let's go ahead and try and reduce that. And, actually it's just 6, all right? So that is 6 times pi. Now, here's where directions come in important. 6 pi inches. If I asked you for exact, the answer would be 6 pi inches. However, it says round to the nearest hundredth. So I can go ahead and go to my calculator and type in 6 pi. Remember, we're using the pi button. We're not using 3.14. And so that is 18.85 inches is the length of my arc. So just keep track of your directions. If it says to round to the nearest hundredth, then you're going to round. Exact means, well, exactly that, exact. Okay, example 10. Find the length of arc JL. Now we know that JL is 135. So the length of JL is equal to, again, it's x over 360 times 2 pi r. So 135 divided by 360 times 2 times pi times radius here is 14 centimeters. Now let's get that numerator. 135 times 2 times 14. So that gives me 3780 over 360. Sorry, 3780 pi over 360. Now, let's divide that by 360 and reduce. Gives me 21 pi over 2 centimeters. Again, that would be the exact. However, with the directions to say to the nearest hundredth, I can just do 21 divided by 2, and that is going to be 10.5 times pi. 21 pi divided by 2. I messed up there. 32.99 centimeters. Okay, example 11. Find the length of MR if PR is 13 feet. So PR is 13 feet. We want to find the length of arc MR. MR is this. So we've got to figure out exactly how long that thing is. Now, something else that I'm seeing here is I am seeing a diameter of MT, which means I have 180 degrees there. So what that means is that since angle TPR is 50 degrees, that means that angle MPR is 130 degrees. Therefore, I can go ahead and set my equation up. The length of arc MR is equal to 130 over 360 times 2 times pi times 13. Now, this time I look at it and I see nearest hundredth. I'm just going to go ahead and type this all in and show you how to do it all in one fell swoop. 130 divided by 360 times 2 times pi times our radius of 13. And we've got 29.50. 29.50. Oh, and I need to get my feet in there. Okay, now the place where I said we're going off our deep end. Not really, not too bad. Okay, radian measure. Theta of a central angle is the ratio of the arc length to the radius of the circle. Now, think of this that we had, I described this a while back. Radians are essentially a way of measuring an angle with respect to the radius. And so if I traveled all the way around the circle, you're traveling a whole distance of 2 pi. Then that means that half a circle, a semicircle, is half of that, which is just 1 pi. 90 degrees would be a fourth of 2 pi, which is pi over 2. So those are the kinds of things we're going to get as our answers here. Now, here's the actual formula for it. Theta, which is the number of radians, a radian value, is equal to the arc length L divided by the radius of the circle. So it's making a ratio of the distance around that we traveled around the circle to the radian, or to the radius. So theta equals L over R. Theta equals L over R. And remember that L has its own formula, which is x over 360 times 2 times pi times r, and that x is in degrees. So find the length of arc AB. Now in this case, we're looking for L, and it gives us theta, which is our measure. So this is our radians, this is theta. So 2 pi over 3 is equal to L over, our radius is 7.5. So now we're just going to cross multiply and solve. That gives me 3L is equal to, and then I'm going to cross, that was came from there, cross multiply the other way, 2 pi times 7.5. Well, 2 times 7.5 is 15 pi. Now we're going to divide both sides by 3. 15 divided by 3 is 5 pi. So L is equal to, nearest hundredth, 5 pi. And so we've got 15.71, and that was centimeters. So, I mean, I guess I was wrong. We didn't actually need that, but good to be prepared. 13, last example. Find the length of AB based on this value. Our formula again is theta equals L over R. So theta is 5 pi over 8 equals L over our radius is 15.1. Now let's go ahead and cross multiply. 8L is equal to, and 5 times 15.1, 75.5 pi. So now we're going to the nearest hundredth. I'm going to go ahead and do that all in one go. 75.5 pi divided by 8 gives me 29.65 centimeters. All right, well, that is it for our lesson today. Thank you all for paying attention. I know, like I said, this is not the best, most ideal way of learning, but hey, we do the best that we can. Everybody wash your hands. Use your Purell, all your Germex stuff, hand sanitizer. Wash your hands anytime that you're out in public. Just take care of yourselves and stay healthy, stay safe, and as always, stay patriotic.